Hi, my name is Soumya. Indian vehicles have major mechanical and electrical components and very little electronic components until 1980s. The engine emissions from the conventional vehicles forced to invent the components which has to reduce the engine emissions. In such case, many electronic equipments introduced in the vehicles to monitor precise the air-fuel mixture, monitor ignition timing and reduce emission. If any problem occurs in the electronic system, it is necessary to obtain the data and based on the data we can identify the problem. The Engine Control Unit (ECU) is the brain of the engine. It's a small computer that receives information from various sensors and tells the fuel injection system how much fuel to deliver, the timing of spark plug ignition, and speed of fan blades depending on the temperature of the coolant. The ECU also controls other functions such as idle speed. Now we are going to learn the electronic components and obtaining and interpreting the data.
At the end of this demonstration, you will be able to state the types and the functions of sensors and actuators, test engine electronics, obtain the scan tool data, and interpret the results. Tools required: Trainees Toolkit, equipment required, a vehicle in running condition, scan tool, materials required, soft cloth. Nowadays, automobile vehicles use sensors and actuators to monitor the air-fuel mixture quantity and the engine emissions. The complete engine electronic system contains various sensors and actuators, ECM, etc. The various sensors are: oxygen sensor, engine coolant temperature sensor, air intake temperature sensor, manifold absolute pressure sensor, mass airflow sensor, throttle position sensor, knock sensor. We will see the sensors one by one and its functions. Oxygen sensor. It measures the proportion of oxygen in the exhaust gas. It sends signal to the ECM. Located in the exhaust manifold or exhaust pipe. Based on the information from the oxygen sensor, the air-fuel ratio can be varied by the ECM. Latest vehicles have two oxygen sensors on both sides of the catalytic converter. Temperature sensor. Two temperature sensors are used in automobile engine and its systems. Engine coolant temperature sensor. The engine coolant temperature sensor senses the temperature of the coolant in your car's engine. When the coolant gets too hot, the sensor sends a signal to your vehicle's computer, which starts to rotate the cooling fan so that air can enter and cool down the engine. When the coolant temperature returns to normal, ECU cut off the signal to the cooling fan. Intake air temperature sensor. The intake air temperature sensor senses the temperature of the incoming air and sends a signal to the ECU, which in turn adjusts fuel and idle speed according to temperature. If it fails, your car might overheat or stall when idling. Manifold absolute pressure sensor. It is also called MAP sensor. It is threaded directly into the intake manifold. Some MAP sensors mounted in the engine compartment and a vacuum hose connected from the intake manifold. Monitor the amount of airflow into the engine. Based on this, ECM calculates air density. Throttle position sensor. Throttle position sensor is also called TP sensor. It senses the position of the throttle body. Based on that, it gives report to the ECM. The ECM calculates and finally supplies the correct quantity of fuel into the engine. Mass airflow sensor. Mass airflow sensor measures the air mass flow into the engine to determine how much fuel to inject. It is used in conjunction with the coolant temperature sensor and outputs a voltage that changes depending on the amount of air entering into the engine. When more fuel is needed, it will send a signal to the fuel pump, which increases fuel volume to ensure proper combustion in the cylinders. Cam and crankshaft position sensors. These sensors are used to tell the Engine Control Module (ECM) or Fuel Injection Control Module (FICM) what position the camshaft and crankshaft are in. When one of these sensors fail, the engine will not start because it cannot determine how much fuel to add, nor will it be able to correctly time when the valves should open and close. Cam sensor failure is indicated by a check engine light (CCL) on the dashboard. Like that, many sensors are used in the engines. Similarly, many actuators like fuel injector are used in the vehicles we drive every day. An eco actuator is an energy-efficient replacement for many of the traditional mechanical actuators that are currently used in vehicles today. An ECM is connected with all sensors and actuators, and it is the main controller of all processes in a vehicle. An ECM is made up of three parts: the control unit, which receives information from sensors and gives commands to actuators; the data processing unit, which analyzes received data and decides on appropriate actions; and finally, the memory unit, which stores information for later use by other units or by itself. Now, we are going to see how to scan the engine ECM. This is useful because it allows us to see if there are any other problems with the engine that need fixing. It is not very difficult and can be done using an inexpensive device, which we will also discuss here. Identify the data link connector in the vehicle. Normally, it is available at the bottom of the steering. Connect the scan tool with the data link connector. Ignition on the car. Switch on the scan tool. Select Enhanced Scan in the scan tool. Similarly, enter the model, make, and year of manufacture, etc. Select Read DTC. Now, you can find the fault with the codes in the monitor. For example, it shows MAP sensor fault. Then, go and check the sensor connections and the sensor resistance. Rectify the fault and then erase DTC in the scan tool. Again, read DTC till it shows no DTC. Similarly, we can actuate the components like purge valve for charcoal canister and EGR, etc. For example, select the actuation tests. Under this, select fan speed. Now, increase the fan speed shown in the scan tool. Now, the electrical fan will run even if the engine is not running. This means we can check the functions of the actuators with the scan tool.
Till now, we have learned different types of sensors and actuators and how to test the engine electronics with scan tool. Many sensors are measuring the temperature, cam, crank, vehicle, engine RPM, position, speed, etc. If any problems with the sensors, we can use scan tool to identify the problem. Based on that, we rectify the fault by tracing the wiring and checking the sensors. Hope you're clear on this. Carry out scan tool exercise with the help of your instructor. Record the fault shown in the scan tool and rectify the faults. Thank you.